Alright guys, let's see if I can verbalize what this tabular probability is doing for us. So what we have here is we have a table of values, and in this table we have executives. There's 48 of them. We have production workers. There's 92 of those. And then the total. So we have 140 total workers. Now within those workers we have Democrats, we have Republicans, and we have independents. So if we just look at the executives, 5 of the 48 are Democrats, 34 of the 48 are Republicans, and 9 of the 48 are independents. So we can kind of break down that what we know per executive, what their political affiliation is. Also, we know that the grand total of independents are 17 out of 140. So just to get an idea of how this table's working. Now, when breaking down the questions, the first one is, what's the probability of picking a Democrat? So if you were just to go into this work environment and pick a Democrat, you would find that they're all home because they're quarantined. But let's pretend that we're not. So of all the Democrats, we have a total of 68. 68 out of 140. So P of D, or the probability of a Democrat, will be 68 out of 140. Make sure you're reducing your fractions, and you'd get about 48.6%. Part A, the second part of Part A of the example says what's the number of executives, or the probability of executives. So the probability of executives would be the total number of executives, which is 48 out of 140. Reduce that fraction, or get a percentage of about 34.3%. Part B of the example says compute D given E. So that's compute the probability of getting a Democrat given that you're only talking about executives. So we've gone through and we've eliminated all of the data except for the 48 executives. So given that we're talking only about executives, what's the probability that they're a Democrat? So it would be 5 out of 48, or about 10.4%. C is asking, are the events D and E independent? They are not independent because if we were to get rid of all the Democrats, would it affect the executive numbers? And vice versa. If we were to get rid of all the executive numbers, would it affect the total number of Democrats? And the answer to both of those questions is yes. So therefore, Democrats and executives are dependent on each other because their probabilities would alter if we got rid of one of them. Or as we saw in the previous example, if we said that we were just talking about executives, then Democrats, the probabilities change. For part D, it says compute D and E. So D and E means that they are Democrats and they are executives. So once again, we're talking about the entire group of people. What's the probability that they are both a Democrat and an executive? Well, I noticed 5 Democratic executives out of 140. So therefore, it would be 3.6%. Now you might be thinking, well, that's an and statement, so you want to multiply. That's fine as well. You could take the probability of a Democrat, the probability of an executive, which would be 48 out of 140, and then the probability of a Democrat, given that we've already selected an executive, so that would be 5 out of 48. And then you multiply those together, and that would be the same thing as the 5 out of the 140. The second way is a little more complicated, so I'm not going to keep giving that example, but just to make the connection of the and the multiplication, that's where that comes in. Now to compute D or E, now you're saying I want a Democrat or an executive. So if I wanted a Democrat, I'm looking at a total of 68 out of 140. Those are all Democrats. Well, executives are 48 out of 140. So that gives us a combine of 116 out of 140. However, as we pointed out earlier, there are 5 Democratic executives that we counted under the Democrats and the executives. So are these mutually exclusive or not? Can they happen at the same time? Well, they did happen at the same time. Right here, they are both Democratic and they are executives. And since we counted them in the number of 68 and we counted them in 48, we must subtract that overlap from one of those two numbers. So the way your math would look is it would be 68 out of 140 plus 48 out of 140 minus 5 out of 140. Because if we count those 5 Democratic executives here, we can't count them there. So we had to subtract. Or if we count them here, we can't count them there, so we have to subtract. So either way, we have to subtract the 5 Democratic executives, and you should be getting the answer of 79.3%. Now, guided exercise 9 goes through the same exact thing that I just explained, but working with independents and production workers. So very similar problems. Take a look through the exercise, take a look through what they explained, and then what you should be finding in your homework is that they're going to be echoing the similar problems. So see if this explanation works out, try it out, submit something, and then what I'll do is I'll look through what you have, and if I notice that one of the answers are wrong, I'll be submitting the answers and my work tomorrow, where you can then go ahead and take a look at your work, see if it makes sense or not. If you're still confused, reach out and I'll explain it. If not, I think there's a great lesson to be learned to try to find your error and do a little error analysis to be like, okay, where did I go wrong? How can I improve this? So take a look at this if you need to. Submit your work. I'll take a look at it, get some feedback to you guys tomorrow, and we'll go from there. You guys are doing awesome. I really appreciate all your hard work, and I couldn't be asking more of you guys. Keep up the great work. Really proud of you guys.